Hello, Professor and everyone. First of all, we would like to thank our Professor Sang Soo for giving us an opportunity to be in his research class. For our final research project, we have chosen this detecting fake news on social media as our topic. This is a team project. So as a teammate, I have Joris Jose and Sanjana Reddy in my team. And now let's talk about our project. So in our project, we have covered this content. We have included the introduction and major problems of this fake news, the purpose of creating this application, and architecture, methodologies, technique we have used, result we got, and the conclusion. And we have also included all the reference that we use for our project. So as we all know that fake news exists way before from social media, but it multifolds when social media was introduced. Fake news is a news designed to deliberately spread hoax, propaganda, and disinformation. Fake news stories usually spread through social media sites like Facebook, Twitter, etc. As we all know that social media is used for news reading nowadays, and before in the past only professional used to collect the news and publish it, but nowadays anyone can collect the news and publish. Therefore the authenticity of the news is difficult to know, and it is difficult to know because there are also increasing number of fraud website in the internet, which increases the number of fake news articles day by day as compared to the past. And peoples are profiting by the clickbaits and publishing fake news on online. More clicks contributes to more money for content publisher. So the major problem is by clicking on the clickbait, user are lead to a page that contains the false information, and false news and information influence the people's perceptions. Therefore, the rise of this fake news has become a global problem that even a major tech companies like Facebook and Google are struggling to solve. It can be difficult to determine whether a text is factual without additional context and human judgment. So the purpose of our project is to develop a method for detecting and classifying the fake news stories using natural language processing. And the main goal is to identify the fake news, which is a classic text classification issue. We gather our data, pre-process the text, and translated our articles into a supervised model features. Our goal is to develop a model that classifies a given news article as either a fake or true. So the delimitation we have faced is like our system does not guarantee 100% accuracy. The system is unable to test the data that is unrelated to the training data set. And there are usually two types of fake news, like visual based and linguistic based type. Visual based are like Photoshop images and videos which are posted in the social medias, and linguistic based are mainly the manipulation of text and string content. This issue is with blog, news, or emails. Now my friend Sanjana will continue.
Hello all. In this project, we propose a machine learning model to identify whether a news article is fake or not based on its content. We used NLP to detect the fake news. There are several attempts made to use artificial intelligence technologies, specifically machine learning techniques and NLP, to detect fake news and stop it from spreading. As human beings, we can read a sentence or a paragraph. We can interpret the words with the whole document and understand the context. Given today's volume of news, it is possible to teach a computer how to read and understand the difference between real news and fake news using NLP. In this project, the main building blocks are dataset and machine learning algorithms. We got our dataset from Kaggle website where data is published for research purposes. Our dataset consists of 7,796 rows and 4 columns. The first column is unique ID. The second column title means the headline of the news. And the third column text is the description of the news. Our data is pre-labeled with fake and real news, fake and real. So we have two classes to our data, fake and real. And initially we used 30% of the data for training the machine learning model and remaining data to test a model that is trained. Um, Now coming to the workflow of our model, our machine learning process consists of the following steps. Once first we load the data set. Once the data set is loaded, we need to pre-process the data set by cleaning the text, applying some tokenization techniques, removing stop words and drop the duplicate words. So once we have this set of pre-processed data articles, we need to represent them into a numeric format. We call this step as vectorization, where we extract the future. Next step is to build a classification model from the extracted data and test and evaluate the model in order to predict the outputs of the unlabeled data. Uh, So to analyze and model the text after it has been extracted, it must first be converted to features. Techniques we use to convert the data to number format is TF-IDF vectorization, which is term frequency and identity term frequency. We use the classifiers like passive aggressive classifier and k nearest neighbor classifier to train and test the data. Trained model needs to be tested and evaluated for accuracy on data that it was trained on. So after training the data, we calculate the accuracy and we compare the accuracy of the two models, KNN and PA, to select the best classifier for building our model according to the accuracy of the classifier while predicting on the test data. So we verified accuracy of our two models using confusion matrix. Next, our friend Joris will explain the techniques we used in our model.
Hi Professor. Here we used the techniques TF-IDF. TF-IDF is the basis for the PA algorithm. That is a inverse document frequency, that TF-IDF. The accuracy is showing here TP plus TN divided by TP plus, that is a true positive and a true negative. That means that is a real news. And compared to that, the total how many news is coming, that is the accuracy calculation, the basic method. And after that, we already discussed this TF-IDF. This is the how many real news in a total number of documents. Per document it will calculate first, and after that it will multiply with an inverse frequency. That is the how many total number of documents are there. So that it will remove all the stop words. I mean the commonly used English words and all. On that way it will calculate and it will give the value. That value is the basis of the algorithm. And this KNN algorithm is the k nearest neighbor. This algorithm is better in the case of a small data set. So the PA is better for the large data set, but KNN is better for the small data set. Yeah, this PA we already discussed. This is in our after our execution also we saw this is a better algorithm for our case also, because large data set is using. So in the real-time application of our project like a Twitter, they are finding the fake news. They are using this kind of algorithm, passive aggressive algorithm. So this is an online learning algorithm, I can say. And the next slide. And my friend sent the result is that yes, this result we will show you directly. This is a and this is a result we are getting. So we use less number of data. We have the P algorithm, but the KN algorithm is better in the case of less number of data. But P algorithm is working very better when we have a large number of data. This is so we have a confusion matrix also. after our result execution, and on that way you can confirm our result. So my friend Sanjana will give the details of the code. Hi Sanjana, you can explain.
So we wrote our code in Python language. First, we started by importing all the libraries such as NumPy, MLExtend, train split, TF, IDF, vectorizer, confusion matrix, accuracy score, k nearest neighbor classifier, and passive aggressive classifier. The first step is to load the CSV file using the Panda function method read CSV. So after loading the data, we need to pre-process the data. I mean, we need to remove, first we remove the label from our data set, that is fake or true. Then we need to divide the data to training data and testing data. This is the syntax of dividing the data to training and testing. So after that, we have to convert these, our data set is in the form of Word, we have to convert it into number format. So for that, we used this TF-IDF vectorization, and we converted the Word to number format as shown in the result. Here we converted each and every word in the document to the number format using TF-IDF. So after converting that, we classified the future extracted data using KNN and PA classifiers that will be explained by Joris.
Hi Professor. This is the execution of our project. Actually, we have the we are splitting the our data to training data and test data. So we are testing our result with the with our total data. We have a total nearly 8,000 rows. So this 0.99 means 99% is using for the accuracy testing. I mean the training, how many data is coming, how much, the 99%. So I can run this, and we can see the result here. Is showing I mean when the 99% test data is coming, the training data is only 1%. So it's a very small amount of data. In that case, the PA classifier has only 83% of accuracy, but the KNN classifier is better, 75% it has accuracy. So I am just changing this to sorry, yeah, 0.01. In that case, 1% only will be test size, but the 99% for the training data. So in that case, a lot of data for the training, and the accuracy is increased. So the PA classifier is better on large data, but the KNN classifier, that is not better. I mean, earlier it was 75, now it's decreased to 65%. And this is the confusion matrix it is showing, and this is our data, and this is a splitting of the data, and we are taking the vectorizer. I mean the common words, stop words, English stop words we are not using, so that we are giving here, and after that the test data we are transforming, and that is we are printing. We can see the passive aggressive classifier result is taking like this, and this is storing to PA classifier, and that prediction we are using here as a score. So this is we are seeing the result, and in that and the confusion matrix also it's printing that we can see here. And even this is also we can use instead of the Excel file, we can use as one sentence of news like this one, and it will show whether this is correct or not. Here you can see these newses are showing as fake according to PA and KNN class algorithm. And about the confusion matrix, my friend Dava will explain.
Okay, thank you. So like here we can see this plot figure. Like here, like whenever we are using the data 0.99%, like we are getting this 2445 as a true positive, and 686 as a true false negative, and 2758 as a true negative, and 383 as a true positive. So here it displays the effect of a classifier. Here we can see the relationship between the label and classifier's performance. And whenever we were using only 0.01%, which is 80 rows only, then we get this confusion matrix where 37 is a true positive, and 25 is true negative, and 1 is true negative, false negative, and 1 is true false positive. So now let me show you my PowerPoint screen. So the result we have written here, like when our training data size is approximately 80 rows, the PA classifier has the higher accuracy, and KNN has only 75%. So PA classifier is best for detecting our fake news. And so this is the screenshot of our confusion matrix. So in conclusion, we came that when we use TF IDF vectorizer and have implemented the fake news detection model using KNN and PA classifier, PA algorithm accuracy increases when the training data increases, and KNN algorithm accuracy decreases proportionally to the training data decreases. And when the training data size is approximately 80% rows, the PA classifier has higher accuracy of 83%, and KNN has 75.5%. But when the training data size is 7,900 rows, the PA classifier accuracy is 98.44, and the KNN is 62%. So the accuracy of PA classifier is higher. So we selected this as the best ML model to detect the fake news. So overall, the performance for our data set was better with PA classifier. Also, the confusion metrics have been plotted, and accuracy value have been measured for the performance analysis purpose. So these are all the references. So thank you so much for listening to us.
Thank you so much, Professor.
Thank you, Professor.
For